Hello students, in this video let us discuss half-range Fourier series, particularly sine series. Fourier series contains only sine term called sine series. We know that only sine term means Bn is there, only one Fourier coefficient we need to find here. Let's see the formula to find this. So there are two half intervals that we have discussed in a previous video also. In a fixed interval 0 to pi is a half interval, and in arbitrary interval 0 to L is a half interval. And we are discussing the sine series. We need to find only Bn. Students, what you are done in the case of odd function, that we have to follow here. So whenever it is odd function, we calculated is Bn only. Same way, when you are finding sine series, we find only Bn. So we find Bn over the interval, fixed interval 0 to pi. So it is the formula 2 by pi 0 to pi f of x sine nx dx. The same over the interval 0 to L, arbitrary interval is 2 by L 0 to L f of x sine n pi x by L dx. So sine series given by f of x equal to summation n equal to 1 to infinity Bn sin nx over the interval 0 to pi. Similarly, summation n equal to 1 to infinity Bn sin n pi x by L over the arbitrary interval. So let's get started with the problem solving. Okay, let's solve the problem. Here we have find half-range sine series for the function f of x equal to x into L minus x in the interval 0 to L. So given that half interval, and we need to find sine series and arbitrary interval. So therefore, correspondingly, the Fourier series for this type of interval is given by f of x equal to n equal to 1 to infinity Bn sin n pi x by L. For where Bn is given by the formula 2 by L 0 to L f of x sin n pi x by L dx. So let us start solving this integration to complete the Bn result. We substitute f of x, where f of x is given that x into 1 minus x in the interval 0 to L, half interval 2 by L keeping as it is 0 to L, and we substitute. So x into L minus x, keep sin n pi x by L dx as it is. Next, this x into L minus x can be written as Lx minus x square. Lx minus x square. This L into x minus x square sin n pi x dx. Then we integrate this by Bernoulli's rule of integration. So that is, keeping 2 by L as it is, Lx minus x square is the first function here. This is u and this is v. We get Lx minus x square keeping as it is, integration of sine will be minus cos n pi x by L, and coefficient of x is n pi by L. Next we do minus alternative sign we have to take, and differentiation of the previous first term will be L minus 2x. Then integration of cos is minus sine, cos is plus sine, this minus retains. So minus sine n pi x by L divided by n pi by L whole square. Next we take plus differentiation of L minus 2x, previous first term will be minus 2, and integration of sine gives minus, this minus is plus now. Minus into minus plus cos n pi x by L divided by n pi by L into this power 3. Then apply the limit 0 to L. When you substitute upper limit L to the term, and also when you substitute lower limit x is 0, so this term becomes 0, because when you substitute x is L, here L gets cancelled. When you substitute x is 0, this becomes 0. So in both the interval, the midterm becomes 0. Next we see the first and last term, what happens. So can be written as it is 2 by L. When you substitute x is L, L square minus L square. This L square, because x is L square minus L square, this becomes 0. Okay. Next we have minus 2. When you take x is L here, x is L, we get cos n pi. So cos n pi we keep as it is, cos n pi. Or you can write it is minus 1 power n directly, divide by n pi by L whole cube. Can be written as L cube by n cube pi cube. Now we substitute lower limit. There also this term becomes 0. X is 0, this is 0, this is 0. So this complete term becomes 0. You are applying lower limit. This minus 2 become plus 2 now. Plus 2 cos 0 is 1. 1 by L, n pi by L whole cube can be written as n cube pi cube in the denominator into L cube. Then we take minus 2 into L cube n cube pi cube out. So we get that is minus 1 power n minus 1, and this L gets cancelled. We get finally minus 4L square n cube pi cube. This is our Bn. Next we write the Fourier sine series what we have the result Bn. So we have, what is the Fourier sine series? F of x equal to summation n equal to 1 to infinity Bn sine n pi x by L. So now substituting Bn, what we obtained, substituting that, so we get here 4L square divided by n cube pi cube, and 1 in the bracket 1 minus of minus 1 power n, and this sine n pi x by L writing as it is. Now you can keep 4L square by pi cube out, remaining all written under the summation. This is our required half-range sine series. Half-range sine series. Now let us take the problem. Find half-range sine series for the function f of x equal to x cos x in the fixed interval, fixed half interval 0 to pi. So what we have to find? Half-range sine series. For that we have to find that Bn. So given by the formula for the half interval 0 to pi, 2 by pi 0 to pi function f of x sine nx, because we have the pi range dx. Then we substitute for the function, it is in 2 by pi integral 0 to pi x into cos x sine nx dx. Now we have to integrate this. For next integration, we need to simplify this sine nx into cos x using the transformation formula. So that is written as 2 by pi integral 0 to pi x keeping as it is, and it is sine a cos b, it is a 1 by 2 sine of a plus b, that is sine of n plus 1 into x, plus sine of a minus b, sine of n minus 1 into x, then with respect to x. Next, this 2 gets cancels. We can write this as 1 by pi integral 0 to pi. Now we have to apply the Bernoulli's rule, where x is the first function, and you could write x into sine of n plus 1 into x plus sine of n minus 1 into x dx. Now using Bernoulli's rule, this complete part is v and x is u. What we get? It is 1 by pi, keeping x as it is, integration of sine, it is a minus cos of n plus 1 into x divided by n plus 1, again minus cos of n minus 1 into x divided by n minus 1. Next, we take minus sign and differentiation of this x will be 1, and integration of minus cos is minus sign of n plus 1 into x divided by n plus 1 whole square minus sine n minus 1 x divided by n minus 1 whole square. For this, the limit what we are applying 0 to pi. So when you apply upper and lower limit to this term, becomes 0 because sine n plus 1 into pi, because n is a positive integer and sine 0. For both the limits, this sine term become 0. So you no need to write that all. Okay, now let us concentrate only to the first term, applying upper and lower limit, what happens. So just we analyze like this. Into pi is what? It is minus 1 power n plus 1. Can be written as minus 1 power n. Similarly, the same is cos of n minus 1 into pi. So now applying upper limit to the term, we get 1 by pi, we have x there, and we have minus here, minus cos of n plus 1 into pi. So that is minus of minus 1 power n. This minus eliminates, we get plus minus 1 power n divide by n plus 1. Similarly, plus minus 1 power n divide by n minus 1. This pi gets cancelled and we take minus 1 common out, and we take LCM. We get n square minus 1 in the denominator. We get what here? N minus 1 plus n plus 1. So minus 1 plus 1 gets cancelled. Our solution of Bn is minus 1 power n into 2n divided by n square minus 1. But since the denominator having n square minus 1, we have the values of series start from n equal to 1 to infinity. So this result is not valid for n equal to 1 because denominator becomes 0 and it will be infinity. Then what will be the B1? When n equal to 1, what is the result? So we find B1. B1 is what? 2 by pi integral 0 to pi from the basic formula f of x, what is x cos x, and sin nx. When n is 1, sin nx becomes sin x dx. And also we know that the formula of sin x into cos x and 2 sin x into cos x can be written as sin 2x. So therefore you can write B1 as 2 by pi integral 0 to pi into sin 2x x into sin 2x divided by 2 dx. This 2 gets cancelled. Next we get, it is 1 by pi, applying the Bernoulli's rule of integration, x into minus cos 2x by 2 minus 1 into minus sin 2x by 4. Apply the limit 0 to pi. So whenever you apply x is pi, sin 2 pi, sin 0, this becomes 0. So now just substitute for upper and lower limit to the first term. It gives us, applying upper limit, it is a minus pi, cos 2 pi is 1 divided by 2. Applying lower limit 0. So then finally is what? It is minus 1 by 2. Then how we have to write the series? We know that series can be written as f of x equal to a summation n equal to 1 to infinity Bn sin nx. Bn sin nx. Where Bn, what we have found, it's not valid for n equal to 1. So you have to separate n is 1 from this series. Can be written as B1 sin x. Next, summation n equal to 2 to infinity Bn sin nx. So what we have, it starts from n equal to 2. The valid. So we have n is minus 1 power n, 2n divided by n square minus 1. So let's substitute that. B1 is minus 1 by 2. So therefore minus sin x by 2 plus summation n equal to 2 to infinity 2n minus 1 power n divided by n square minus 1. This is Bn sin nx. So this is required off range sine series for the given problem.